प्यारे बच्चों, today we will start one another type of oscillator called Colpitts oscillator, which is one variety of LC oscillator. First one was the Hartley, and this is the circuit of AC equivalent circuit of Colpitts oscillator. The basic difference between Colpitts oscillator and Hartley is only combination of L and C. This is the tank circuit, or you can say feedback network used for feedback. In Hartley oscillator we have two inductors, one capacitor, and in Colpitts oscillator we will use two capacitors C1 and C2 and one inductor L. And other components are same and connection is same. That is very similar to Hartley oscillator. Only difference between Colpitts and Hartley is combination of, instead of L1 and L2 we are using C1 and C2, and instead of C we are using L. So this is the AC equivalent circuit. In AC equivalent circuit all DC connections are shorted and capacitors, coupling capacitors are shorted, and this is the AC equivalent. Here R is the combination of three resistances. One is the output resistance of this transistor, another is resistive effect of inductor or tank circuit. Resistive effect of this circuit is included in this, and third one is load. Any load present in the circuit is included in this resistor. So this is the AC equivalent circuit. And for a small signal equivalent circuit we can draw the model of transistor. So this is the model. Input resistance is high, so that's why this is open. So this is a dependent current source which depends on the input voltage. Input voltage is V pi, and this current depends upon this input voltage. You can see easily connections. R is connected between collector and emitter. So that's why we are connecting here in between collector and emitter, which is grounded. So this connection is grounded. So R is in between collector and emitter. Similarly, C1 is connected between collector and emitter. So here we are connecting C in between collector and emitter. What about C2? C2 is connected between base and emitter. One terminal is connected to base, another terminal is connected to emitter. So here C2 is connected between base and emitter. All these terminals are grounded. So these are same emitter. All these terminals are same. So C2 is connected in between emitter and base. So this is the connection. And this is the last component L, which is connected between collector and base. So this is connected between collector and base. So this is the small signal equivalent circuit using model of transistor. So from this circuit we will derive frequency of oscillation for Colpitts oscillator. We will use this one for the derivation of frequency of oscillation. So rule is same, that is very similar to Hartley oscillator. In Hartley we have applied KCL at the output node. Similarly, this is the output node V0. So apply KCL at output node. So what are currents? We have four currents: 1, 2, 3 and 4. These are four outgoing currents. So you can write V naught upon impedance of capacitor, that is 1 upon SC1 plus V naught upon R plus GM V pi plus this one. Current is this branch. That is voltage divided by total impedance, that is SL plus 1 upon SC2. This must be equal to 0. So this is the case here. At this output node, all 4 currents are outgoing. No incoming current is there. Therefore, all these 4 currents, 1, 2, 3, 4, this must be equal to 0. So from here, we can replace value of V pi. What is V pi? V pi is the part of voltage of output which is obtained at this capacitor C2. So we can apply potential divider. This is the voltage drop across C2. So 1 upon SC2 in numerator and in denominator 1 upon SC2 plus SL into V0. So this is V pi. You can replace and you can write this is SC1 V0 plus V0 upon R plus case of, you can use SC2 is cancelled. So you can write here Gm into 1 upon SC2 into V0 upon 1 upon SC2 plus SL plus V0 upon SL plus 1 upon SC2. This must be equal to 0. Now you can take V0 common. Okay. And you can simplify it. You can take LCM. So from here, first simplify this part. Then we will write SC1 V0 plus V0 upon R. From here, this is SC2 is cancelled out plus you can write Gm V0 upon 1 plus S square LC2. And here this is V0 SC2 upon 1 plus S square LC2. Same factor. Both are same. So now you can take common V0. So this is equal to 0. So you can write. So writing directly, you can see when we are taking common, so terms are here GMSC2 so you can write GM plus SC2, these two terms, GM plus SC2, this is plus, this factor is multiplied 1 plus S square LC2 into this, that is 1 upon R plus SC1 whole divided by this term 1 plus S square LC2. So this is equal to 0. So after applying this here, this is the expression. From here you can see, since this is equal to 0. When you will multiply this, you will get V naught into, in numerator you have Gm plus Sc2, these two term plus this one, plus 1 plus S square Lc2, this one, plus into 1 upon R plus Sc1. This is equal to, but V naught is not equal to 0. Therefore, another factor is equal to 0. That is Gm plus Sc2 plus 1 plus Lc2 into 1 upon R plus Sc1. This must be equal to 0. From here, you can write so put S equals j omega. Then what is, you can see this is Gm plus j omega C2 plus, what is this value? 1 plus S square, that is 1 minus omega square Lc2, and this is 1 upon R j omega C1. This is equal to 0. Now you can separate real and imaginary parts. So what are different parts? This is the real part, and you will multiply this. So this into 1 by R is the real part, and this term will give you imaginary part. So first we are writing real parts. So Gm plus 1 upon R and minus omega square Lc2 upon R. These three terms are real. This term is real, and multiplication of this term by 1 upon R. So these two terms are real, and three terms are imaginary. J omega C1 multiplied by this and j omega C2. So you can take j omega common. This is the, and what are terms? Here you have C1 plus C2, C1 from here, C2 from here, and another part is minus omega square L C1 C2. This is equal to 0. Okay. So this is the part of imaginary part. J omega C1 multiplied by this will give you omega C1 and j omega C2. So this will give you C1 plus C2, and this term j omega C1 into this. Okay. This last term omega square L C1. So this is the separation of part into real and imaginary part. So now you can find out frequency of oscillation. So this is whole term is 0, means putting imaginary part equal to 0 means C1 plus C2 minus omega square L C1 C2 equals 0, and this implies omega square L C1 C2 C1 plus C2. So what is omega square? This is C1 plus C2 upon L C1 C2. Or you can also write this like 1 upon L into C1 C2 whole divided by C1 plus C2. And this part is the series combination of C1 and C2. So you can write this is the C equivalent. So you can write omega square equals 1 upon L C equivalent, where this equivalent is given by C1 plus C2. Okay. So this is omega square. Now you can find out under root LC equivalent. So this is the frequency of oscillation. From this you can write this is 1 upon 2 pi LC equivalent. So this is the expression for frequency of oscillation. So this is frequency of oscillation. Okay. And second part is condition. What is the condition of oscillation? When we will put real part equal to 0, we will get the condition. Condition of oscillation. Putting real part equal to. When we will put real part equal to 0, real part is this one. We have three terms in real part, Gm plus 1 upon R minus omega square LC2 upon R. This must be 0. So from here you can write replace value of omega square. What is omega square? You can write it omega square LC2 upon R. This is equal to Gm plus 1 upon R. And what is value of this? Omega square is simply 1 upon LC equivalent. That is 1 upon L C1 C2 upon C1 plus C2. So from here you can replace this value, and after replacing this value you will get in condition. Replace this value of omega square. Omega square means 1 upon LC equivalent, that is series combination of C1 C2. This is series combination of C1 into LC2 upon R. This is equal to Gm plus 1 upon R. This is cancelled out. C2 is cancelled out. Okay. This comes to numerator C1 plus C2 upon C1 into 1 upon R This is equal to Gm plus 1 upon R. And this term is, right, 1 plus C2 upon C1 into 1 upon R. This is Gm plus 1 upon R. Okay. Or you can write 1 upon R plus C2 upon C1 into 1 upon R. This is equal to Gm plus 1 upon R. So this is cancelled, and from here you can write C2 upon C1 C2 upon C1, this C2 upon C1 equals Gm. So this is the limit. So this is the condition. And what is frequency of oscillation? This is 1 upon under root L C equivalent. Let's say L C equivalent. This is for Colpitts. And for Hartley, what is omega? This is 1 upon under root L equivalent C. Okay. And what is condition? Condition for that is L1 upon L2. This is Gm of R. So this is for Hartley, frequency of oscillation and condition, and this is for Colpitts. So this is all about Colpitts oscillator circuit. First draw the circuit of Colpitts oscillator, then draw the equivalent circuit of Colpitts oscillator, then apply KCL at the output node, then solve for frequency of oscillation. You have to separate real and imaginary part. From imaginary part you will get frequency of oscillation, and from real part you will get the condition of oscillation. So this is all about Hartley and Colpitts. Okay, thank you.